Hey everyone! We're coming up on our last project for the semester, which is the Desmos art project that I'm really kind of excited about. We're going to do this in two phases. So the first phase is going to be this video here, and really all I want you to do is follow along with the video and go through each step that I do and submit your graph at the end. That way you know all of the stuff that needs to be in your art project and can focus more on the creative aspects. So let's get started right away. We start off going to desmos.com and click the button to start graphing. So we created a new graph. One of the helpful things in Desmos is that Desmos lets you write comments to what you're doing. And this can be very helpful when you're doing a big art project because you might want to separate things based on what they are in your pictures. So to add a comment, you click this little plus icon up here and click Note. And then say, this is my art project, or something along those lines. And a note or a comment doesn't really graph anything on your picture. It's just a way of you making a note to yourself that you can use later. Another thing that's very helpful in Desmos is the folders. So the way we add a folder here is by clicking this plus icon and clicking on the folder button here. And I would like you to create a folder here called parent functions. And you can just type the phrase parent functions and hit enter. And you notice how this little line going down from the arrow? Anything that's in this line will be part of this folder. And what's nice about these folders is you can show and hide the functions that are in them by clicking on the little arrow. So the arrow pointing to the right means that folder is closed. The arrow pointing down is it's open. And anything with that line in it is part of that folder. So for your art project, you're going to need to define 8 different functions. So we're going to go one at a time to make sure you know all of them that you need. So I'm going to name my parent functions with f and then a number. So my first one I'm going to name f1, and then to define a function, you got to open parentheses and put a variable like x. And after you got that, you put an equal sign, and the base parent function for a linear function is just x. Now, for your project, you can use any linear function, like 2x plus 3 is still a linear function, as far as I'm concerned. But I'm just going to leave this as the base parent function for now, and you can get creative with them later. So function number 1 is a linear function. For function number 2, I'm going to define a quadratic function. So just like before, I'm going to type f and then the number 2. Then I'm going to put some parentheses around an x. That's how we make a function definition. And then after the equal sign, I'm going to do f to the second power. You can do this either using the caret symbol on your keyboard, which is Shift 6, or by going to the software keyboard and there's a square button here, or to do other exponents, you'll use that button there. So x squared is an example of a parent function. And like I said before, you could have other functions that are also quadratic, like x squared plus 2x plus 3 is another kind of quadratic, but I'm just going to leave it as x squared for now. Our third function should be a cubic function. So I'm going to define an f3, and rather than having whereas quadratic function has a x squared term, a cubic function has an x to the third power. And that's our quadratic or cubic function. So again, you could have other kinds of cubic functions, but x to the third will work for our parent function. A square root function is going to be our fourth function. So I'm going to define f4 of x is equal to a square root of x. You can do this using the software keyboard. You can see the little square root symbol down here at the bottom, or you can type sqrt. And once you type in the t in sqrt, it will put in the square root symbol for you. And inside the square root, I'm just going to put x. So that is my square root function. I'm going to hit enter to go to the next line. And my fifth function should be a reciprocal function. So I'm going to define f5 of x to be a reciprocal function. And the way you can do a reciprocal function, you can type 1, and then you can either use the division key or the slash key on your keyboard to turn that into a fraction. And in the denominator, I'm going to put x as my denominator. So that's our reciprocal function. We also want to have an exponential function. So f6, I'm going to make my exponential function. And your exponential function is any number to a power of x. So for example, you might do 2 and then use the power button or caret symbol on the keyboard to put an x there. You could use 10 to the x. I like to use a number e, which is a Euler's number. And you'll see that in later math classes. It's not really important what this number e is, but technically e is this number 2.7182 and so on and so on. I like this e to the x graph because I think it's pretty. So that's the exponential function that I'm going to use. And I also want you to have a logarithmic function. So for f7 of x, you actually have your choice of 2 logarithmic functions. So if you go to the functions menu, and I think it's under MISC, you see this log button or ln button. Either one of these two will work. Log x looks like that, or ln looks like that. Either one of those 2 functions will work for your logarithmic function, but have one of those 2. And I'm going to use this ln of x because I'm using e to the x here, because ln of x is the opposite of e to the x. They are inverse functions. Log of x is actually the opposite of a power of 10. Ln x is the opposite of the power of e. For your 8th function, your 8th function can be a wildcard function. So you can use any function you want for number 8 here. Play around with some of the functions in Desmos. There are some really cool stuff here. Some of these trig ones look really cool. Like, I'm a big fan of sin x, gives you this nice little wave function here. Tan x is kind of cool also. If you're familiar with geometry, that can be some fun stuff for you to work with. There's some other functions, like you could do abs. X is the absolute value of x, which is also these little bar symbols here that you could use here. The little bars of x is the same graph. They're also, the pipe symbol on the keyboard is right above the enter key. There's some other functions that you might want to use, like this floor function can be fun. It creates this like step ladder kind of graph. Basically, for your 8th function, pick anything you want. The goal of that wildcard function is for you to get some creativity going so that you can do whatever you want. I'm going to change this back to sin x because I feel like it's pretty. So those are the 8 functions that you need to have defined. That wildcard function can be any one of the functions that you feel like is cool in Desmos that you want to use in your picture. So those are my 8 parent functions. I'm going to collapse that folder for now so that I can get those definitions out of the way. And I'm going to create a new folder to house all my transformations, because there are 6 different transformations that you need to have in your art project. So I'm going to group them all in a folder, and I'm going to call that my transformations folder. So the first kind of transformation you have is a horizontal shift. So for a horizontal shift, I'm going to define a new function. I'm going to call my transformations all g's, and I'm going to call my first one g1. So I'm going to do g1 of x. And a horizontal transformation, you can use one of your parent functions that we defined up here as part of your transformation. So let's say that, you know, I've got this purple graph here was my quadratic equation. If I want to do a horizontal translation of that graph, what I can do is I can reference it by its name, which was f2, and then in parentheses, the way that I do a horizontal translation is by adding or subtracting inside the parentheses. So if I want to slide it to the right, I can subtract something like 4. And you see now I've got a copy of this parabola that's been moved over to the right. So this parabola has been translated to the right. If I wanted it to go to the left instead of the right, I would just flip this sign around. For your translation, it doesn't matter whether you go left or right, just as long as you've got some kind of horizontal translation. So I'll leave that how it is for now. Our second is a vertical translation. So I'm going to define this one, I'm going to call this one G2 of x. And since I used my quadratic already, let's move along and try this with the cubic function. So my cubic function is this black one that's kind of an S shape, kind of tilted. Whereas the quadratic was F2, the cubic is F3. And if I want to do a vertical translation, rather than adding and subtracting inside the parentheses, I need to add or subtract outside the parentheses. So if I want to slide this up, I can add something to it, like 3. And now you see that this black graph and this purple graph here, one is the same, just shifted up. If I wanted to shift it down instead, I could try a negative number like -1, or anywhere in between. Let's try maybe +5. Get it all the way up to the top. So that is my vertical translation. The next transformation you need is a horizontal reflection. So for a horizontal reflection, let's use our f4. So our f4 was our square root function, which is this red one here. And we're going to use a horizontal reflection to flip this over the y-axis. So I'm going to call this G3 of x. And my parent function for the square root function was f4 of x. But if I want to flip it horizontally, I need to change this x inside the parentheses to be a negative x instead of positive x. And you can see it flipped from here to have a horizontal reflection. Next on our list, we need to have a vertical reflection. What's a fun vertical one to do? I kind of want to do a vertical reflection of my sine graph. So my sine function was f8. I think it'll look cool if I flip that vertically. So I'm going to define my G4 of x to be my vertical reflection. And where my original function that I want to play with is f of 8, but where the horizontal reflection, the negative sign was inside the parentheses. For a vertical reflection, the negative should go outside the parent function. So if I put a negative here, now you see that my sine function has now flipped and I have this sort of double helix thing going on across my graph. So that's how you do a vertical reflection. The fifth transformation is the horizontal dilation. So the horizontal dilation, what's a function we haven't used yet? Let's say, how about that reciprocal function? That'll be interesting. So my reciprocal function was f5 of x. To do a horizontal, or where's my function here? So it's the blue one. So to do a horizontal dilation, what you need to do is you need to multiply this function by something inside the graph. So we're looking at this blue curve that's kind of here and here. And if you multiply it by something inside the parentheses, it kind of shrinks a little bit. So it went from here to here. If I shrink it even further, I can shrink it like to there. It gets kind of tighter. Large numbers shrink it horizontally, like squish it like this. If you want to stretch it out horizontally, you use a small number like 0.5x. We'll make it stretch out this way. Let's stretch it out to like 0.1x. We'll stretch it out, make it nice and big. So that gives me my horizontal dilation. The last transformation that you need to include is a vertical dilation. And what's another one that we haven't used yet? Well, I've used 2, 3, 4, 5, 8. So how about F6? F6 was which one? F6 was my e to the x curve, which is this one here. So my e to the x curve looks like that. And I'm going to stretch this vertically. And the way that we do a vertical stretch is by multiplying outside the function. So I'm going to try this with a big number like 5, and you can see it kind of shifted from here to here. If I want to shrink it vertically, you can use a number less than 1, like 1/2 or 0.1. Let's do like a nice 2. So I've got from there to there is my vertical dilation. So those are my 6 transformations that I'm required to have. Horizontal and vertical translation, horizontal vertical reflection, horizontal and vertical dilation. Those are the 6 types of transformations we need. But you now notice that I have a whole bunch of functions on this graph. I don't really want to see all of them. So one of the ways that you can adjust these graphs is you can just click on these buttons to turn them off and on. So I'm going to actually go through all my parent functions, and I'm going to hide all of my parent functions here. Except for this sine one, because I kind of like that double helix that I've got going on. But you do want to make sure that you're using all of these functions here. So let's think of some other ways. Well, I've already used, I need to have function 1 showing, so let's make sure function 1 is showing. I need to have a linear function. I've got my linear function is f2, quadratic, cubic, then I've got my square root, I've got my reciprocal. I'm missing f7, so let's turn my log function back on. And now I've kind of got all 8 functions are being used, all 6 transformations are being used. Basically, at this point, I've met all the technical requirements of the project. So anything else beyond this is really just for fun. So some of the things that you can do with this is, in addition to changing the function, turning them off, on and off, one of the things you can do is if you click and hold on this icon over here, it will open up a style and color menu. So say I don't want this function to be green, say I want this function to be purple. Well, I can click purple and change it from green to purple. I can also change the style. So if I don't want solid lines, maybe I want dashed lines, I can use a dashed line. I could also use a dotted line. And these different styles and different colors can give you a lot of things to play with when you're doing your creations. One other thing that I want to talk about is how to limit the domain of a graph. So let's say that I'm going to turn off this log, or let's say I want to use this logarithmic function, which was this black one here, but let's say I don't want the whole thing. So one of the ways that I can do this is, let's say I want to use this graph f7, but I don't want to have the whole thing. I only want to have it going up to here. So let's say I want it to stop at x equals 4. The way that I can do that in Desmos is by restricting the domain of this function. So if I want all the numbers that are less than 4, I can do these little curly braces, and in the curly braces type x less than 4. And then I can come back up to my parent function here and turn the original off by clicking the button here, and then I only have the piece of the function that I want. You can also limit this on both ends. Like, let's say I want it to start right here at 1. So I could type 1 less than or equal to x is less than 4, and then I don't have the full log function. I've just got a little piece of the function. So as long as you're using a little piece of the function, that counts. So, I don't have to have my original shown because I've got my log function here, but I'm only using a little piece of it. Couple things now that I've shown you sort of everything that's expected in your project here. I'm going to rename this graph. So I'm going to rename this to my art project phase 1 and click the save button here. If you're not already signed in with your Google account, it may ask you to sign in with your school Google account, and then all your creations will be listed on the graphs over here. So whenever you need to come back to this, you can come back, sign in, and then click on this and have your saved graphs over there. So that's how you save and go back to your graph. The last thing you need to do is share a link. So to share a link, you can click on this share graph button here. You can either click the copy button here, we'll copy it to the clipboard, and then you can either right click or Control V to paste it into the Google form so that I can see a link to your graph. That's the basics of the requirements for the art project. For phase 1, I just want you to go through the video, try to recreate all the steps that you saw me do here, and it doesn't have to be a coherent picture. It can just sort of be a bunch of different graphs that you've played with, and we'll worry about the actual picture making next week. So that's it for today. I hope this recording was useful for you. Thank you.